Hello and welcome to another video. In this video I'm going to show you how to sketch any piecewise function. As long as you know how to sketch the components of the piecewise function. So, for example, if you look at the first one, this is a quadratic and a linear function. You have to already know how to sketch a quadratic and how to sketch a linear function, and then you can sketch a piecewise function. You just need to pay attention to these numbers and what's going on here. That's all. And then for the second one, it's a cubic function and an absolute value function. You also have to know how to sketch those different functions, especially if you know what the parent function looks like. Okay, once you're able to do that, then you just need to pay attention to these numbers, -2 and 1 and 4, and also know what's going on here, so you know what to do at those points. That's it. So I already presented a template for each of the questions. We just have to do some rough work or just get an idea of what the shape is going to look like, combine them, and this video will be over in no time. Now, if you already know what you're supposed to do, stop watching, just go do your work, okay? But if you don't know, then you should keep watching. Let's get into the video. So let's tackle the first thing first. And the first thing to tackle is to just look at the pieces of the function. Remember, it's a piecewise function, so which means it's not one function, it's a function that is broken in pieces. And many times a piecewise functions will not be the same function on top and under. That's why it's a piecewise function. So you have a different shape of the first part and a different shape of the second part. So do you know what the shape looks like? Do you know what this would look like? You need to first imagine and know that the function that goes before you get to 1, so this says all values of x that are less than or equal to 1, so that's on the left hand side, and this second part says all values of x greater than 1 be on the right hand side. So it's always good to have an imagination of what your graph will look like. So you're going to have a first part that is quadratic. Remember, the graph of a quadratic always goes this way if the leading coefficient is positive. Okay, so you're expecting something that goes up, and when you get to this part, you're expecting a linear function with a negative slope. That's something that will slope to the left. So what you're looking for is something that combines a quadratic with this line. It has to look like this. Now, where the relative positions will be, we don't know yet. How high up we're going to go or how low we're going to go, we don't know. But you're looking at something that looks like this. Also, you have to be able to tell what the shape looks like and what the shape looks like. Okay? This is the shape of x cubed. So a cubic function will always have a certain shape. You need to know what it looks like, and so you can imagine what your answer is going to look like. So you expect something that looks like an n. I always assume the letter n, something like this. That's what a cubic function would look like, okay, because it's positive on this side. Now, what does the other one look like? It looks like this. It looks like a v. All absolute value functions with a leading coefficient of positive anything will always be like this. So you're trying to combine this with this. You're coming from the left to the right. With this, your next focus is just to figure out what relative positions you're going to get. Where will this end? Where will this begin? Where will this end? Where will this begin? And that's what you're going to place on these graphs, and you'll be done. So let's start with the very first question. So the first thing we're going to do is sketch this part for all values of x that are less than 1 or equal to 1. So look at this. You see, the only thing you need to pay attention to here is that you're looking for values of x that are less than 1, but they could also be equal to 1. And you see, this means when you mark this point on the graph, you have to shade it. Remember, it's an inequality. So that has to be not an empty circle, but a shaded circle. That's all. That's all you need to know. But you have to come from the left of the graph. So how do we sketch a quadratic? There are two strategies here, okay? The first and the best is just know what the parent function of all quadratics are. So note this. Let me do the work here. Whenever you sketch a quadratic, the parent function is f of x equals x squared. And all this graph looks like this. Okay? But this is not what we're sketching. We're sketching x squared minus 2. That means there's a translation of -2. So you're translating, you're pushing the graph down 2 units. So if this was 0, this was -1, -2, the graph you're actually looking for looks like this, but you push this down 2 units. So this is the actual graph. The second one I sketched is the graph you're looking for. And it goes from anything less than x, which is less than, less than 1, up to when you get to 1. Well, when you get to 1, when x is 1, x squared minus 1 is going to be, x squared minus 2 is going to be what? Negative. That's going to be 1 squared, which is 1 minus 2, that's -1. So you're going to get x is 1 and y is -1. So this is the point, and you have to shade it. That is the end of the first part of your graph. That's all. You have to shade it. So it comes all the way from -infinity, it gets to 1, and because this is or equal to 1, you just shade this. If you use transformations, because you're using the parent function. Now, for those of you who don't know that that's the parent function, which you should know, okay? If you're doing this topic, you should know that that's what it looks like. The parent function of a quadratic is simply a u sitting here. And then anything else you do is a transformation of it. But let's say you don't want to use transformations. Why don't you just make a table? Plug in the values of x, and then you calculate the values of y. Now, what values of x will you calculate? This is my recommendation. Let me clean this up. So my recommendation is the end, start from the end and go backwards. Just pick some very nice numbers you could use, okay? So what I'm going to do is I'm going to pick x equals 1 and y will be equal to what value? So I'm going to pick one, the end of it, then I'm going to go back, okay? Before 1, I know I'm going to get 0. Before 0, I know I'm going to get -1. So it's easy for you to make your points here and then sketch it. Eventually, you'll see how it goes. And once you start going to the left, just stretch it and it goes. So at this point, I have x, then I have f of x, which is going to be x squared. So this is going to be 1, and this is going to, oh, it's x squared minus 2. I have to remember that. Okay, that's what I have on this side. So this is going to be 1 squared minus 2, which is -1. Here it's going to be 0 squared minus 2, which is going to be -2. There's going to be -1 squared minus 2, which is going to be -1. And then there's going to be -2 squared minus 2 is going to be 4 minus 2, which is going to be 2. So I got 4 points, but you see how I started from the beginning, from the ending, because I want to focus on this. I don't want to do beyond that because we don't go beyond 1. So you start from here, and this will be included. In fact, just to make myself smart, I'm going to not use this. I'm going to use this. Okay? Just to tell me that I have to shade this particular point. These other points are not of interest. They're just locations, but I have to shade this. Or just do the normal coordinate pair. Okay? Just do this. And make sure you state that this is included. Okay? Why is it included? Because this says or equal to. Now, when I do the second part of this problem, I won't do all these explanations because now I'm taking the time to explain it. When we get to the next one, we just apply what we're learning now. Okay? So let's go to our graph and sketch this. So if you plot these points, you will notice that you can always start from this one. When x is 1, y is -1. When x is 1, y is -1. So I'm going to shade this point. Okay? When x, oh, I just use this. I know it's going to be like this, and I'm going to stop there. And this would be the vertex. Okay? So my graph actually goes this way. And when x is -1, y is -1. So it goes here too. And then when x is -2, y is 2. When x is -2, y is 2 right here, somewhere here. Okay, so the graph goes this way. So this is shaded like this. Yeah, that doesn't look perfect, but this is all you need to sketch. Okay? That's it. This goes indefinitely like that. which is a reflection of this if we remove this part. You see? You didn't need to make this table if only you knew your graph is just supposed to go down here and end here. It's the same thing as what we did there. And you have sketched your graph. Remember, this point will be shaded. Make it obvious, okay? A giant circle with a bold shaded dot in the middle. That's tautology. Okay, but let's just move on. Basically, that's what you do if you don't know what the parent function is. Make a table, choose the correct values, and plot them. Okay, now let's go to this one. Now I know how to sketch a linear function. It has a slope of -3. The y-intercept is +5. I know all that. So how do you sketch a linear function in this case? I'm going to get rid of, okay, I'll leave this here. And we want to do this, but look at the values we need for this one. All values of x greater than 1. Is 1 a point of interest? Yes. You're still going to identify that 1, but instead of you shading it like you did here, you will not shade it. Okay, so let's go. Firstly, there are two ways. You can make a table also, or you just sketch a line. You can sketch this. Okay, it has a slope of -3 and the y-intercept is 5. So this is what I'm going to do. The y-intercept is 5. 1, 2, 3, 4, 5. So definitely the line goes through here. Because it has a slope of -3, it means if I go down 3, I'll move 1 right. Okay, so I can say, okay, yeah, we just do that. So this is going to be 5. 1, 2, 3, move 1. So it has to go through this line. Okay, so it's something that goes like this. Or you just plot the graph. See, or I already have a picture of what my graph will look like. Okay, it's going to look like this. Remember, it's a sketch. So 100% accuracy is not what's important. The most important things in this kind of problem will be the shape that you have, this point, this kind of point that you need, and what this looks like. So where does this start? This other line does not start all the way from the beginning. No, it starts from all values of x greater than 1. So 1 is of interest. And what would be the value of the function when x is equal to 1? Let's put 1 here. -3 times 1 gives us -3. What's -3 plus 5? That's 2. So when x is 1, y is 2. So the point of interest here, let's change this. So because we're going to the right, it's okay to start from 1 here. Because you're using values of x that are greater than 1. So you can actually start with 1. And this will be -3x plus 5. This is going to be 2. If you pick 2, what will be your value? Your value is going to be -6 plus 5. That's -1. Uh-oh, it's down. So it's just going down along this line. So what we're going to do now is pick this point, 1, 2. This is the point 1, 2. Where is the point 1, 2? 1, 2, right here. Are we going to shade it? No, it's going to be an empty circle. Make sure you make it obvious. It's going to be an empty circle. So that's the point 1, and y is 2. And, you know, the rest of it doesn't matter. Just go straight down, like that. You're done with the sketch. That is the graph of this function. Now, two things you want to do so you understand what you've done is to write out the domain. What is the domain of this function? That is, what values of x can you plug into this function? Looking at the graph, you can find your answer, or looking at what you're provided with, you can find the answer. Okay, so let's look at it. All values from -infinity up to everywhere, because there's no hole here. There would have been a hole if there was a hole here, but this blocked it. So it's going to be every single value. So the domain of this is from -infinity to infinity. That's the domain. Or you can go here and look at it. All values of x less than or equal to 1. So from -infinity to 1, yes. And anything greater than 1 also. So it means it's all real x. So you can use that. And what is the range? Okay, so for the range, what are all the possible values of y? Well, this tells us that you're going to -infinity. This tells us you're going to +infinity. Is there something in the middle that we skipped? Nope. There's nothing that we skipped in the middle. So it's still all values of y from negative infinity to infinity. We have finished sketching this function. Okay, to solve this and this, all I have to do is know what this looks like. So the parent function of x cubed is something that looks like an n and goes through the middle. So remember, it's something that looks like this. Okay, it looks like that. That is the graph of x cubed. But the problem we have is not just x cubed, we have x cubed plus 4. And remember, when you have this bold 4 added to the function, you're moving the entire graph up. So this thing is supposed to be 1, 2, 3, 4. This line here is supposed to be here. Let me use another color. So this is what your graph is supposed to look like, something like this. Okay, so your graph is supposed to shift up like that. If this is what we are plotting, x cubed plus 4 just moves up like that. So likewise, the absolute value function has a parent function that is like this. But you see, we're not plotting this. We're plotting this minus 2. And if you understand how transformations work, when the argument has something being done to the independent variable, if you're subtracting 2 from the independent variable, the graph will be moving to the right 2 steps. If you're adding to it, it will move to the left 2 steps, just the same number of steps as the number you're taking away from it. If you're taking away, it moves to the right. So this graph is not going to stay here, just like this didn't stay here, went up. Okay, this one is going to move to the right to counter this subtraction. So what you have here is, if this is 1 and this is 2, your graph, instead of being here, is now going to be here, like this. So this is the graph you're going to get. So I want you to imagine the combination of this graph with this graph. So you should be looking at something that looks like this, combined with something that looks like this. You just want to know where which starts and where which ends. That's it. Okay? It's a combination of this and this. So this topic requires that you already know, like I said in the introduction, that you already know how to sketch each of these graphs. You just want to know how to combine them. So now, let's talk about the combination. The first part. Where does this red guy start here? Let's go to the graph. It says for all values of x from negative 2 to 1, and you have to include this negative 2 because it's negative 2 is less than or equal to. So we're going to be shading the negative 2, but we'll be leaving the 1 empty. We're going from negative 2 to 1 for this one. So this is going to be negative 1, this is going to be negative 2. Whatever value we get for negative 2, we have to, so it's going to be somewhere here. We're going to shade it, and then we stop at 1. 1 will be on this side. We're going to leave it empty. So it's going to be something like this. Okay? And remember, this point has to be 4 because that's what the graph is. So our graph is going to go through the point 4. Where is it? 1, 2, 3, 4. We're going to have a graph that goes like this. Let's talk about what happens at negative 2 because that's the beginning of our plot. It's not from infinity or negative infinity rather. So let's see what happens. What will the value of this function be when this is negative 2? If we plug in negative 2 here, negative 2 cubed will be negative 8. What's negative 8 plus 4? That's negative 4. Oh, that point is wrong. It has to be down. So this graph is actually going down to negative 4 when this is negative 2. So we're going to go look for a point on this graph where where x is negative 2 and y is negative 4. So this is negative 4, negative 2 right here, and we have to shade it. Put a circle and shade it. Beautiful. And then we know that we have to pass through this point 1, 2, 3, 4 because that's the point where x is 0. Go back. When x is 0, you notice that the function will be 4. 0 plus 4 gives you 4. That's why the transformation goes through 4. Okay? Now, we're going to have this 1, 2, 3, 4. We're going to use this point. And the other point is when x is 1. When x is 1, what will this function give us? It's going to be 1 cubed plus 4. That gives us 5. So we're looking for 5 here. 1, 2, 3, 4, 5. So it's going to be here. But it's going to be an empty circle. Remember? Not shaded, this shaded, not shaded, and it's an an N that goes through 4. That's going to look like this. Let's see what it looks like. The graph is going to look like this. No, that's not good, Newton. Let's fix it. So we're going to have something that looks like this. This is going to be an empty circle, and then it goes this way. Something like that. Remember, it ends here. You don't go beyond this point because your graph starts from -2. You stop at -2, and then it goes here, and it ends also. There's a limit right here. So that's what your graph is going to look like. And then the other part begins from 1 to 4. We're going to go here now and say we're starting from 1. Well, this is 1. It has to be somewhere here, and it has to be a circle, an empty circle. And then it ends at 4, which is also supposed to be an empty circle. You see? So you have two empty circles attached to this graph. We just want to know what this value is and what this value is. Okay? So let's go back. Let's plug in 1 here. What is 1 minus 2? That's -1. What's the absolute value of -1? It's 1. So it means that when our x is 1, remember you can make a table for all these things, okay? So when our x is 1, y is 1, so we need an empty circle here. Okay, and remember this is sitting at 2, or you just make a table and plot values from 1 to 4, okay? Maybe we should do that quickly. If we make a table and we have x, and this absolute value of x minus 2, if you start from 1, 2, 3, 4, you're going to have absolute value of 1 minus 2, that's 1. Then you put 2, 2 minus 2, that's going to give you 0. Okay, the second point is 0. The third point is going to give you 3 minus 2, that's going to be 1. 4 minus 3 is going to be 2. So these are the points. So you're going to be 1, 1. We plotted 1, 1. The other point is this point. And the third point of interest will be when it's 4, which is 4, 2. 4, 2, 1, 2, 3. 2, 3, 4 rather. And this is 2. So it's going to be right here. And this goes this way. Okay. Yeah, I know my graph looks weird, but that's how weird it's going to be. That's why it's called a piecewise function. So let's wrap this up. Let's get the domain and the range. The domain of this is simply where it starts from and where it ends. As you can see, we started from -2. So the domain is simply from -2. I'm using a brace because this is shaded. We use a brace. It continued to the right until there was a break. Okay? And the break was not shaded. So we're going to say it stopped at 1 or took a pause at 1 and then continued after 1, which is a union of this other range. So this other interval, which is going to be from 1 again. And it continued until it got to 4, but 4 also is not included. So we're going to use parentheses. So that is the domain. We change the shape because this is shaded. If it is empty, always use a parenthesis. If it is empty. If it is shaded, use a brace. Okay, the next one, the range. The range is the set of values of the output. Now the outputs are all the numbers that you can read on the y-axis. Well, we started from the lowest value here, which is -4, and it's shaded. So we're going to say it's -4. It keeps going all the way up to 5. Everything here is taken. There's no break as you're going along the y-axis. And it got to 5 and stopped. But 5 is not included. So that's what you have. I hope this makes sense and I hope this helps. If it did, make sure that you leave a comment in the comment section and you give it a thumbs up. Okay? And what else should you do? Be subscribed, okay? Subscribe and hit the notification bell so when the next video comes up, you'll be one of the first to know. I'll see you in the next video. And never stop learning. Because those who stop learning, stop living. Bye-bye.